All right, so let's take a look at variables in Rust. And so this will follow along a little bit with chapters 3.1 and 3.2 of the book. Not super closely, but I know the book will cover a lot more, but we'll take a look through some of the ideas. And so first, let's take a look at some code. Let's read through and kind of compare it to what we might know from other languages. And so right here, we have some lines of code. We can see we have some equals signs. We have some pretty consistent things here. We have like this let keyword used quite a few different times. And then we also have like some variables here. And so, or I guess a value, we have the number 10. We also have a variable a that's being referenced that we created before maybe. We also have this mute keyword. And so we're going to be taking a look at that a little bit. And a little bit about data types as well. And so right here, where we see something that is an I32, so we'll examine that a little bit. Now, if we compare this to other languages we might use before, we might be familiar with a keyword to say that we're going to start making a variable. And so in JavaScript, you might have something like const or let. But on the other hand, in Python, you might just have something like a equals 10. We also have like the semicolon. And so similar to what you might have seen before in Rust or in some other systems languages or just other languages in general, a semicolon implying the end of the line here. Okay, so let's hop into the Rust playground and write out some of the things that we were seeing before. And so I'm going to start off pretty nice and easy just with a simple variable. And then let's see how we can sort of like take a look at what it is. And so I'm just going to say let a equal 10. Awesome. And then I'm just going to use a debug here. So it's just going to print out whatever is inside of a. And I'm going to end that off. And let's give this a run and see what happens. Okay, so once it runs, we will see in just a second that it should just print out 10. Now, a little bit of information about this DBG here. I'm just using it because it's a nice shorthand to get something printed out from the terminal. Okay, awesome. It printed right here, a equals 10. Debug's also nice because it does give some extra information sometimes about like where that line was called. And so maybe instead of just printing it to the terminal, I can actually see more context about where the information was being debugged. Now, it's a macro, and so that's what the exclamation mark is here. That's why it's like in the short form. If I wanted to print something, I might do it a little bit differently. But anyways, I digress. Let's take another look here at the variables. So when I assign 10 to A, that's awesome. I was able to print it out, and it's all fine and dandy. Now, let's say I wanted to do let B equal 5 as well. And then I'm going to say let C equal A plus B. And then let's instead debug C. So I'm going to run this, and I'm just going to close this off while it's executing. Let's take a look and think what we might expect here. Now, if you're familiar with many other languages, then you'd look at this and say, okay, well, A and B, you got them together, that's 15. That makes a lot of sense. That's going to be put into C, and then we're using C later. Okay, so we were able to trace it through pretty well. But what I want to think about right now is what other things might it do, or what might some weird things that we throw at this do. And so one weird thing that you might have seen in other languages is if we add like a 0.0. What does this mean? If we're familiar with something like Python, or I think JavaScript would allow this just fine, we might just expect it to turn into 15, and it's happy, it's fine and dandy. But on the other hand, in some other languages, we would say, okay, well, this is being interpreted differently than this. This value that we just put in, the number 10, it's going to be interpreted as an integer. I didn't add a decimal after it, and so the language should interpret it as an integer. On the other hand, when we look at B, we say, okay, there's a dot here, and so maybe I expect it to be a floating point number. And then in that case, what's going to happen when I put them together? Well, first of all, let's just see what happened when we added A and B from before. Let's see. Very cool. Okay, did something go wrong? Okay. Yeah, I didn't add them together. So it should have showed off 15 here, but something in the response didn't go well. So that's fine. But let's take a look here and see, okay, we're going to run this one now. And I'm just going to close it off. And let's think, okay, what might happen? Might it go through and just say 15? Might it not work at all? And if it doesn't work, what would it say to us? Okay. So in this case right here, awesome. We get a little bit more information. We can see when it didn't run, we have cannot add a float to an integer. Okay, well, how did it know that one was a float and one was an integer? Well, in this case right here, we can sort of trace it ourselves. We can say, okay, we have A and we have B. We don't exactly know what the compiler is going to think A is, and we don't exactly know what the compiler is going to think that B is just yet. But we can see how they're used. We can see A is used inside of this evaluation down here, and B is also used inside this evaluation. And so when it puts them together, the compiler should decide right here whether or not something is okay. And in fact, we can see, because it's trying to use the plus symbol, it's like, okay, I expect the stuff on the both sides of the plus symbol to be the same so that I can interact with them. In this case, the Rust compiler is saying to us, it doesn't know how to add an integer and a float together. Now, if we take a look at it, we're like, obviously there's like the solution for it, and that's fine. But then there's also implications down the line as well. If we were to add them together, do we want it to come out as an integer where it doesn't have any extra information about what's after the decimal point? Or do we want it to come out as a float where it does have that extra information? And so it's a bit ambiguous there. We don't exactly know. And so in this case, the Rust compiler will tell us you're not allowed to do that. Now, the way that stuff is happening here is through an idea called, I want to say type inference. I think that's, yeah. I think it's an I word, but I'm pretty sure it's type inference. Yeah. So I didn't specify any of the types inside of here, but Rust is able to say, okay, I'm able to infer that because you put a period here and you have like a decimal place, then this is a floating point number. What we could actually do is explicitly say that I want a floating point number that is 32 bits long. Now we have two options here. We can either say F32 or F64 if I want 64 bits. For the integer, I could say I want an integer that is 32 bits long. And to us now, we can see a lot more clearly this is not going to work because A is an I32 and B is an F64. Now let's go over here and so let me just pop back over 10.0. We're going to tell this to infer what this should be just by how it looks. So we're going to give this a run here. Actually, I'm just going to refresh this because I think it's being a bit funky. Okay, let's run it again. All right. So after we set it running and after it goes through, we see right here that C is 15. And so it had the numbers as we expected. That's all good. But it was able to figure out for itself. It's able to say B is an F64. And I don't know if A is an F64 and F32, but because B is, that I'm going to make A that so that this resolves and this is able to work properly. And so even though I left it ambiguous as to what A was, it was able to figure it out for itself. Okay, we'll hop into data types a little bit more later. This is especially, some of this stuff is especially helpful when we're changing between more complex types as well. So the type inference when we're doing some stuff with iterators and when we're doing some stuff with some just more advanced data types, it helps out a ton. But let's reduce this again and take another look at this mute keyword that we saw from before. So let's start by saying A equals 10. And then I want to say, let's debug it. And before I do that, let's add some numbers to A. So let's say like A plus equals 10. So we're just gonna add another 10 to it, and we'll see what happens here. So what we expect is it adds it to 20. That's awesome, and we're able to print that out, and we're all good to go. Now, one thing in Rust, though, is that variables by default are immutable. That means that after you make a variable, you are not allowed to change it. And so this has a lot of implications down the line of making sure that when you're writing your code, you know exactly when stuff is going to change in the future, or more specifically, when stuff is not able to change. And that helps with a lot of situations. And so, yeah, right here it's going to say you're not allowed to assign twice the same variable. So we have an immutable variable A that you made. You didn't make it mute, and so therefore it's immutable. You set it as equal to 10, but then afterwards you said that you were trying to add 10 to it. That's not allowed. You didn't say it was mutable, and so you're not able to do that. But one really cool thing is the Rust compilers can give us a lot of help here. It's going to tell us that we're able to go and change it out instead to mute A in this case. And so if I'll just follow what it says. Instead of doing A right here, I'm going to go and put in mute A. And let's give this another run. In this case, now that I've said that A is mutable, then it's going to be allowed to change the value afterwards. And so we're gonna be able to add 10 and print it out. So you might think, oh my gosh, I don't like that. I have to add the mute keyword every single place I want to change something. But as we'll start to see, not only with variables, but also with how we pass stuff between functions, we'll find that there's a lot of benefit that comes from being able to specify whether we want to change a variable or not. And so this is one really powerful thing that a lot of functional programming languages will have. And so if you've taken courses on like the programming paradigms course at Carleton or another similar one at a different university, you might have seen these ideas before of when you make a value, you don't really set it to a variable and change that variable over time. It's more like you come up with some big calculation to do so that by the time it gets to where like it is getting assigned to whatever, it's the final form. So in this case right here, we were able to say that a is equal to 20. So hopping back over into our code right here, we took a little bit of a look at how to set variables. We took a look at how data types can be used on top of variables. We also took a little bit of a look at the mute keyword. And again, we'll take a much larger look at this later. And now that we've kind of learned about the mute keyword, we can see the importance of line 7 here, where we're asking C to be changed, whereas we're not asking A or B to change. Now, one interesting thing that I've seen before is this idea that, okay, well, A is immutable, so why am I allowed to just pass it over to B? And it's kind of interesting because mutability cares about whether it can change or not whether or not something else can look at it and use it. And so there are some interesting rules around that, though. We will actually get to explore that in another video, where we'll be able to say, well, if I'm giving this information to another variable, what's the implication behind that? So we'll leave that here for now, and we'll be back next time.